Good morning to one and all. Welcome to today's session on semantic in big data. My name is Ikra Hashmi and I am very thrilled to take you through the fascinating intersections of semantic and big data, exploring how we can driven meaning and actionable instance from vast amount of data. Introduction to big data. We will start with a quick overview of big data. Big data refers to data set of large and complex that traditional data processing tools structure and to struggle to handle them. It's characterized by the 5 V's, which are volume, velocity, veracity, variety, and value. Volume shares the size of the data, velocity, speed at which data is generated, veracity, differ from the data like structured, unstructured, and semi-structured data. Veracity, reliability of data, and the last value, insights the gain from the data. These are the 5 V's of big data, which is helpful for generating and extracting meaningful information from the big data. Managing this data is difficult without understanding its context and meaning, and that's where semantic comes in. What is semantics? Semantics is the study of meanings both in language and data. It's what enables us to move beyond mere data points to understanding the data, while syntax refers to the structure of data. Semantic focus on the meaning. Without the semantic, we can only analyze the data at a superficial level. But with semantic, we gain deeper insights into what data truly represents. Roles of semantic in big data. As you can see that it's divided into 3 subparts, which are raw data, semantic layer, meaningful instance. Now understand them in thoroughly. So why we are semantic so important in big data? In massive data sets, the big data points can be ambiguous or contextless. Semantic help to add meaning to these data points, ensuring that we aren't just analyzing numbers but understanding what they mean in context. This emphasizes scalability, interruptions, and analysis, which lead to more information decisions. Semantic technology in big data. Next, let's discuss the technology that helps bringing semantic into the world of big data. Key semantic technologies include ontology, structured framework to represent knowledge. RFD means resource description frameworks. This is a model for representing information on the web. Sparse SQL, a SQL language that can retrieve and manipulate data stored in RDF formats. And natural language processing, which plays a critical role in semantic analysis, enabling the extraction of meaningful from structural data. It analyzes the structure and context of text to identify key concepts, and relationships, and entities. Ontology and knowledge graphs. Ontology are essentially the foundation of semantic understanding. They provide structure, volume, relationship between concept. Knowledge graph extend by this credit vast network of entities and relationships. For instance, search engines like Google use knowledge graph to give you rich, more evaluate information. In AI, these graphs are used to enhance machine understanding of how things are evaluated. Formal specification of concepts and their relationship in the domain is presented by the ontology, which also provide a structural vocabulary for representing knowledge. It is used in knowledge representation and resourcing. On the other hand, the knowledge graph, which is a large interconnected network of entities and their relationship, often built on top of ontology. This enables efficient information retrieval and resourcing, processing complex query, which is used in search engine, recommendation system, and artificial intelligence application. Semantics in data integration. One of the most significant benefits of semantic is its roles in data integration. Big data comes from a variety of source different platform formats and vocabularies. Without semantic merging these data sets can be like comparing apples to oranges. Semantic provides a common framework allowing data from multiple sources to be combined and understood in an undefined way. This is crucial for business and research institutions where data comes from diverse systems. As you can see, it is divided into three subparts, which are heterogeneous data source, semantic layers, undefined data representation. The heterogeneous data source is big data often come from multiple disparate sources with different formats, database, and vocabulary. Semantic layer act as a unified bridge, mapping and aligning data elements from different sources based on their inherent meaning. And the last, through diverse data sources are integrated into a convex data set, enabling context, analyze, and decision making across different domains. Use case of semantic in big data. It is used in variety of real world scenarios. Let's look at the few real world use case where semantic is meaning as an impact in big data. Healthcare. Semantic enable the seamless integration of patients' record from various hospitals, making it easier to interrupt and share data. E-commerce. Personalized recommendations are possible by understanding not just the product but also the context of users' needs and behavior. Finance in fund detection, semantic help to uncover complex patterns and might not be visible through traditional methods of data analysis. These are the cases highly highlights the power of semanticity in making data actionable and useful as well. Challenges and future of semantics in big data. While semantic offer incredible benefits, there are some challenges. Implementing semantic layer is complex, especially at the scale required for big data. Standardization is another issue. There is still a lack of universal accepted method for representing semantic data. Scalability can also be a challenge as the data set grow exponentially. However, the future is promising. We are seeing AI-driven semantic analysis and real-time semantic process on the horizon. As semantic technologies continue to evolve, they make big data more intelligent and more accessible. In conclusion, semantic plays a critical role in transforming big data into valuable insights by adding meaning and context to raw data. We are able to generate better outcomes and more informed decisions. Thank you for your attention. I could now be to